Welcome to the Spherical Mirror Lab. In this first activity, we're going to make a quick estimate of the focal length of our concave mirror. So I've set it up here in the lens holder, and I'm going to make an image of an object that's very far away outside the classroom. And I'm going to make an image on a screen. So I'll move the screen around until we get a nice clear image. There we go. All right, so there's the image that our mirror is making. And the distance between the mirror and the screen tells us an estimate of the focal length. So let's measure that here. So I get around 8 centimeters, let's say. In the second activity in the lab, we're going to use a technique called auto-centering to measure the radius of curvature of a concave mirror and use that to figure out the focal length of the mirror. If you place an object at the center of curvature of a concave mirror, then you'll get an image formed back at the center of curvature of the mirror. The lab handout asks you to draw a ray diagram to illustrate why this happens and thinking about what kinds of rays are coming from the center of curvature and what a mirror does to those rays. To do this technique experimentally, we're going to use our object screen cover on a light source. So we've got an arrow object, and I'm going to move the mirror back and forth until we get a nice image back on the screen. So this is sort of like auto-collimation using the same image object screen. But it's not really auto-collimation because we don't really collimate light here. We just send the light rays back on themselves and we get an image forming in the same plane as the object. When you're doing the lab, when you do the ray diagram for this, it'd probably be easier conceptually to just place your object right at the center of curvature. Here our object is displaced from the optical axis. The optical axis is maybe somewhere here, and we've displaced it up a little bit so that we can get our image clearly forming down below it a little bit. In your diagram, you might want to just have an object right at the center of curvature. You can also illustrate the situation, instead of having an object going horizontally, just make your object like we normally do, with the foot of the arrow at the optical axis and the tip of the arrow up extending away from the optical axis in a vertical direction. And then you can do some ray diagramming, which the lab handout asks you to do, to show where the image will form for that. Notice this image is inverted, right? And so you can illustrate that in your diagram. And we're going to measure this distance because this distance represents the radius of curvature of our mirror. So we'll go from the light source to the mirror, and I'm getting about 16 centimeters. In the third activity, we're going to explore the object-image relationship of the concave mirror. So I have the concave mirror set up. On the opposite end of the bench, I have our light source, and then I have a screen to find the image on. So right now, I'm not forming a clear image. I'm going to adjust the screen location so that we get an image. And it will be difficult for you to see on the video, but it's a very tiny image, and that's about the clearest image we can get right there. So this is with the object more than a meter away, and the image is forming very close to the mirror. And maybe we just want to have a look at the actual distance. It's around 9-ish centimeters. So you want to think about whether that makes sense for this mirror. So now what I'm going to do is I'm going to move the object closer and readjust the screen position to get a good image. I didn't have to move it very far. So there's a clear image again. So I'll move the object again and readjust the screen. There's the image. And again, you probably can't see it in the video, but it's getting a little bit bigger, the image is. And so I'll reposition the object again, getting quite close to the mirror. Now we'll move the image screen again. Not very far. You can see the image distance hasn't changed a great deal, but it is larger now. Oops, centimeters. It's around 11, 12 centimeters. So I'll move the object distance once again to say here. And then let's move the image screen. There you go. Now you can begin to probably see the image on the screen. I'll go a little bit more. Move the image screen a little bit. And now you notice a sort of funny, odd thing that I'm going to bring the object even closer. And to do that, I'm going to have to pick the light source up. I'm going to put it up above my screen. So I'll bring it about here. And now I will adjust the screen location. All right, so here we have a situation where, roughly speaking, the object and the image are at about the same location. And you can relate that back to procedure 2. And now I'm going to bring the object even closer. So again, here we are in a situation where the object and the image are about the same distance from the mirror. I'm going to move the object even closer, and that will require moving the screen away. And there it comes into focus. Hopefully you can see that. Now I'm going to move the object even closer, and I will push the image screen away. There it's coming into focus. And if you want to see what this looks like, there's about where the object and the image screen are relative to the mirror. So now the image is farther away from the mirror than the object is. It just requires a little fancy negotiating of the equipment to see that. So now I'm going to bring the object even closer, and I'll have to push the screen away like so. There it is, coming into focus. And let's bring the object even closer. I'm going to reposition the mirror a little bit. And there's the image on the screen. And now I'll bring the object even closer. The image is going way out there. And then one more time. There it is. There we go. And even a little closer. Let's see if we can get the image to fall way out there. Barely getting it. So let's have a look at where our object is relative to the mirror. There we are. Quite close. 8 or 9 centimeters, I would say. All right, so to recap, what happened in this qualitative experiment is we started with the light source very far away from the mirror, and the image formed quite close to the mirror. And as we brought the light source closer and closer, the image formed farther and farther away. There was a point where they both formed, image and object were at the same distance from the mirror. Then as we brought the object even closer to the mirror, then the image moved farther and farther away. The second part of procedure 3 is to make a quantitative measurement of object position and image position for the mirror. I've set the object to be somewhere between the radius center of curvature and the focal length, which I believe for this mirror we've determined that the focal length is around 8 centimeters and the center of curvature was about 16. So I've set the object distance to be 12 centimeters. Let's do this right. There we go, 12 centimeters. And let's go find our image. So there's the image, and I think it's clearest right about there. So if we measure this image distance, we find distance of 29 centimeters. take it back, 28.6 centimeters. 28.6 centimeters for the image distance. Now you can use the measured object and image distances to calculate what the focal length and power of this mirror are. In the fourth activity, we'll turn our attention to the convex negative mirror. And the first thing we're going to do is use a method similar to the auto-centering technique that we use to measure the focal length of the positive lens. So in that technique, we put the object at the center of curvature and it formed an image at the center of curvature. Now the problem with the convex mirror is that the center of curvature is behind the mirror, it's downstream from the mirror. So what we have to do is put an object at its center of curvature. That means it's a virtual object, and it's going to create an image at that center of curvature, which is behind the mirror itself, so it's also a virtual image. So to accomplish that, we need to make a virtual object, which means we need to have converging rays falling on the mirror. So to do that, we're going to use a positive lens, and so we're going to have a light source, we'll have our positive lens, it's going to form an image over here on the screen, and these rays are what are going to serve as the object rays for our convex mirror. So here's our convex mirror, we'll put it into place. Those rays that the lens is creating, that's converging these rays towards the image location that was on the screen here. So now I have converging rays falling on my convex mirror. So the object associated with these incoming rays is right over here on the screen. So what we're going to do is we're going to move the mirror around so that the distance between the mirror and where the image is forming by the lens, so where these converging rays are converging towards, we're going to make this distance be the radius of curvature of the mirror, so that this image that's being formed on the screen serves as object for the mirror. We want it to be located at the center of curvature of the mirror. So we're going to move the mirror around until that happens. When that happens, we know that rays that are associated with the center of curvature just get reflected back on themselves. So these rays that are coming in here converging towards this image point, they'll just get reflected. They're going to go back through the lens and go right back to where the object was. So the goal is we're going to form an image on our image screen over here like we often do. All right, so let's go ahead and move our lens around and look to see if we get an image forming on that screen. And I think you can see we are. Let me do a little adjustments here. There we go. So let's get it good and focused. All right, I think that's pretty good. And if we come over here now and look at what this distance is between the mirror and where the image was forming from the lens, we want to measure this distance. It should be telling us the radius of curvature of this mirror. And I'm getting about 19, call it 19 and a half centimeters. 19 and a half centimeters or so for the radius of curvature of this mirror. So you can use that value to go ahead and calculate the focal length of this mirror. Now in procedure 5, like we did for the concave mirror, we're going to explore object-image relationship for the convex mirror. The difficulty is like diverging lenses. For a real object, we are going to get virtual images. They're images that appear in the mirror. So we can't really show them on a screen. We have to just look at them through the mirror. So I'm going to use this rod as my object. So I'm placing the rod a certain distance from the mirror, and then you can see the image in the mirror. And you can see that it's behind the surface of the mirror, a certain distance. And so let's look at what happens as I bring the object closer and closer to the mirror. Hopefully you can see that the image also approaches the mirror. So the object distance is getting smaller and the image distance is getting smaller. You might also notice that the image gets larger as we bring it towards the mirror, and is getting smaller as we move the object away from the mirror. As we move the object away from the mirror, you notice that the image that you see in the mirror is getting further away from us, as well as getting smaller. So I'm going to do that one more time. We'll start with the object right up against the mirror. We'll move it away. You can see the image moving away and moving away. We're going to keep going. We're going to keep going. Now, it becomes difficult at this point to really tell where that image is. It's clearly behind the mirror. And you may remember doing this for the diverging lens as well, that it's difficult to see, but it turns out to be true that as you move the object farther and farther away towards infinity, the image is moving towards the secondary focal point, which is some location behind the mirror, but a finite distance. So as we move this object away from the mirror, the virtual image in the mirror is getting farther and farther away, but it's approaching the focal point of the mirror. And the final activity in part 5 is to actually make a quantitative measurement of an object image distance. So I've set up the object here to be at about 11 centimeters. Ooh. 11 centimeters. And then we're going to look into the mirror. I can see that image in the mirror, and it appears to be about this far away. And I'll go ahead and measure that distance. And when I measure that distance, I get a distance of 4 centimeters. So the object was at 11 centimeters and the image distance was about 4 centimeters. So you can use that to calculate the power and focal length of the convex mirror.